So this week I've been focusing on talking about cross-domain workflows. You will have heard me say those three words, cross-domain workflows, quite a lot. What I'm going to show you now though is a very practical demonstration of what it looks like in action. This is a WK app. This has been built in our specially created drag and drop form builder, which allows us to make full stack applications really quickly with embedded security. I've talked about this separately and we'll talk about this again and again. It's a project that I've absolutely loved since I started it a couple of years ago. But what we're here for now is to look at cross-domain workflows in action. So this is a demo application which shows you how cross-domain workflows can be implemented. What they do is they give you a better inter-domain collaboration as a capability that you can use across government, and they facilitate more secure storage for aggregate data by default. Aggregate data is all of that data that we put together. So taken individually, a record relating to a person potentially is not very damaging, but the records of thousands or hundreds of thousands or millions of people put together are actually a crown jewel data asset. So that's what I mean when I talk about aggregate. For ease of demonstrating this cross-domain workflow application, what we're going to do is go through a guided process. So I've constructed this app to walk us through, and it gives you different views of data moving securely between security domains. So from official to secret, back down to official sensitive. Official sensitive itself is not a security domain, it's a caveat of official. But actually it's just to illustrate that where we have an official system, some of the data it might hold could be caveated sensitive, for example, if it's a personal record. And that's the context in which we're looking at this for ease of demo. So let's get started. And we'll do this by clicking the big green Start the Guided Demo button. So this is step one. And on the server side of our application, our high side and low side applications are generating elliptic curve Diffie-Hellman keys, and they're creating key pairs. So each one creates a private key and a public key as part of a pair. And what they're doing is they're exchanging their public keys so that they can actually be used as part of the encryption mechanism where a shared secret is derived, which we'll come to in a little bit. In production, we would also use an elliptic curve DSA signing key to verify transactions. That's another key which says this has come from the right place, we trust this. So as you can see on the screen, normally you wouldn't see this as a front-end user, but I've put it here just to sort of ease talking about quite a complicated cryptographic topic. The low side public key is shown and the high side public key is shown. These are the lengthy objects here. And now that we've got those keys, we can actually progress through and do the things that we're going to do. So what we're going to do now is click Next Step. So this is step 2 of our demo. What we're going to do here is assume the role of an external user. So a citizen, a public service user, for example, a vetting applicant. And we're going to complete a couple of questions for them from our browser, encrypting those responses. So from our very own personal machine, which has no government security devices or anything attached to it, no monitoring, possibly Norton or McAfee antivirus or something like that, we're actually going to encrypt straight from our browser. And again, what we're going to do is use a JavaScript library to generate another pair of elliptic curve keys. And we're going to use the Web Crypto API, which is just a public API, and we're going to combine that with the public key of the high side application to derive that shared secret. So actually, once that data is encrypted in the user's browser, it can only be decrypted at the very high level domain. So even if it were to be intercepted at a lower level, it can't be decrypted. And all of this sits underneath the usual sort of TLS stuff as well. Obviously, in a production scenario, the user would have already been through authentication. So you think about applications like OneLogin, which is now becoming the standard for all services across government, or some other custom mechanism enabling them to sign up for accounts at higher domains. Other things are available. There are some really good companies out there doing fascinating stuff with cross-domain hybrid architecture. I can think of one that I've worked with previously, but that mechanism is not necessarily relevant here. And this is actually more about the pattern of the workflow. An interesting little note. How can we actually make life easier for users? Well, users on their own machine, they need to have as few demands placed on them as possible. Most people have no experience at dealing with encryption keys or cryptography, and they find it all confusing. And while we can abstract the technical complexity away from them, One of the biggest and most secure things that we can do to make the best of it is actually ask less of them in single turns. So for example, sending somebody a big vetting form, which is all to be completed in one piece, it's not only a bad user experience, but actually opens you up to security problems. Conversely, asking a smaller number of questions over a number of days could actually give you a more structured back-end process too, allowing you to trigger certain types of checks and verifications. But as well as that, it will help gamify processes for users to keep them engaged and actually give them a better and more engaging experience, so you'll get better inputs from them too. So what we're going to do here is we're going to say our first name. So my first name is James, and we're going to be asked this critical question as part of our 2-question form, which is, are you a spy? And it says, if you're honest, it would be really helpful. I am going to say no, because it's asked me to be honest. What I'm going to do now is hit submit, and now we've arrived at step 3. So we've submitted that data. In the back end, we've augmented it to form a dictionary. So what we've done, instead of just having name James and spy no, we've actually added a timestamp to it. We've captured an IP address. We've got a session, and we've got an approximate location for that user as well. So we've just created a bit more contextual data about how they're using the system. Obviously, before encryption, this is plainly visible to anyone monitoring traffic, so that poses a security risk. So a man in the middle, or a man in the browser, or a man wherever, or a man even over the shoulder could potentially see this data. It's relatively trivial to get hold of this stuff. So actually what we're doing is we're using that public key, which has been exchanged from the Highside app, and that Web Crypto API, which I've mentioned before, to automatically encrypt the data the moment the user's filling it in. And that stays encrypted all the way through to storage on the high side. So again, none of this process would normally be seen by users, but it's shown here so you can see what happens. So we have the app's public key and the user's private key. They create the shared secret. The user's public key, the encrypted data, and the non-secret initialization vector are shipped directly across to the high side. That data would generally travel via API, so that's Application Programming Interface, direct to the high side via either a diode, which is one-way traffic, or a high assurance gateway, which is two-way traffic. And they can be quite chatty, by which I mean they can accept a lot of traffic. And actually, HAGs, as they're called, can be stacked as well. So you can expand the amount of traffic that they can handle in a really effective way. Looking at it more closely, what we can see here is the public key from the user. We can see that IV, and we can actually see our encrypted data here. So this is name James, spy no, the timestamp, the IP, the session, and that location has now been turned into encrypted data. So what we're going to do now is click next step, and you can see we've now moved across into our hypothetical secret application. At step 4, that encrypted data packet has made its way across the security domains. So it's gone from outside across official, it's gone up to high, and it can now be decrypted and inspected before any onward use takes place. So for this operation, we use that public key sent by the user, the initialization vector, and the encrypted data, which incorporates the shared secret, and we combine that with our high side private key, which has never left the high side, to derive that shared secret, decrypt that data. And the other thing which is happening as well is we're doing some validation and inspection checks on that data at the point of decryption to see if it contains anything suspicious or executable code. Obviously, those kind of checks are much more robust in production, but I have actually built one out here which checks if there's any malicious code or suspicious terms contained in there. These are well-established patterns, so I don't need to reinvent the wheel with that. But what we can see is at the high side, we've received our encrypted data, our gibberish. We've decrypted it, we've checked it's safe, and only then have we passed it back, and we can see that that data has come back out exactly as it was before. So name James, spy no, timestamp, IP, session, browser location. And that's great because that means we've now got an encryption mechanism which can work from client-side JavaScript all the way through to back-end server code. Now we're into step 5. So because that data is safe to use, it can be saved to a database, a structured relational data. It can be used in systems, in processes. None of that's done here for demonstration purposes. But what we are going to do is present it to our hypothetical authorized user, so somebody logged in with their high side credentials, and present a task to complete. So you can see now they've got this nice little UI and it's telling them there's a vetting application come through and an applicant called James was asked if they were a spy and they said no. So what we now have is information that requires an action. Now, we could interact freely across our own domain because we're over at the high side now. We don't need to worry about cross-domain workflows at all. Or we can start to think about cross-domain workflows and we could look at users with even higher domains or actually lower domains. And in this case, what we're going to do is create a task for a low-side user in another department. So here we are at step 6, still in our secret system. And what we're going to do is we're going to create a slice of information. So if you imagine we've got this full record that we want to keep up high because it's high value, like a vetting record or something like that. But actually a little bit of it can be released back down to the low side. And the way that we do that is we create the slice, so the thing which we know through a human process that we're willing to release downwards, we encrypt it, we send it along with our public key to an individually named low-side user or to a system. And this time we're going to be interacting with a system that we trust with that slice of information. So the service of exchange keys rather than users. Of course, you can individually key it to users too. It's absolutely no problem at all. So this type of interaction is suitable where the receiving system is a government system on an assured government network, where users have gone through some form of vetting or pre-employment security checks, and where endpoint devices and physical site security are managed. So any official government department will have degrees of this in place, so this is perfectly acceptable. Something to touch on briefly here, what is a slice of information and why does it matter? Well, operational practicality is the most common answer to why it matters. Cross-domain workflows allows us to keep aggregate data sets at high side where they're safer. But the reality is the majority of government staff don't and can't practically work high side. Subsequently, a slice is a part of the aggregate which could be dealt with at the low side for a short period of time. For example, it's part of a vetting record or part of some other record, and it's released for the duration of someone carrying out checks on a part of the administrative process. So that's the context in which we're looking at this. So with our mini form here, and this is a gross oversimplification, but it's done to show you and help you see how visually we do this. So which direction is this task moving in? You can see you would normally have options, but we're just going to send the task down. So we know that we're sending it from secret down to official. Now we're going to choose which organization we're sending the task to. And obviously, if you were to configure this completely, you would only make organizations available once they had a cross-domain workflow in place. So hypothetically here, we know that what we were looking at then was a vetting record. So we're going to send this down to UKSV. And the task that we're going to set out is check if James is really not a spy, which is a fair task. And what we're going to do now is click submit. That's going to take us straight on to step 7. This is the last secret step here. So because the public keys have already been exchanged between our systems and they can be rotated at will because they're not linked to persistent storage, we start off with our plain text, which is direction is down. We've added a timestamp. We're pointing at the organization UKSV, and the task is check if James is really not a spy. And what we're going to do now is encrypt that task data. And again, this is something that a user would never see, but it's just here for demonstration. And we can see at the point that that's ready, we have our encrypted data here. So that dictionary up there has been turned into this encrypted data, and that's now safe to send across that high assurance gateway. And here we are, we've arrived at our official system. You can see this is caveat sensitive because this is an area of a system official where we're dealing with private personal data. And this is our final step. So we've actually received that data from our high side system. And in production, this would see checks for malicious or suspicious input in the same way that we saw previously. And you would also automate rejection and deletion if the routing were wrong. So for example, you were the Home Office and you received something for DEFRA. But because this has arrived at the right place in our hypothetical scenario, that data is decrypted using that high side public key and our low side private key to create that shared secret and decrypt that data. So the first thing that we're going to do is view that final shipment of data from the high side as the machine would see it. So you can see that's exactly that same encrypted data that we saw leaving. It's been successfully decrypted, so we can see it direction down, timestamp, organization is UKSV, and the task is check if James is really not a spy. And then potentially, and this again is just hypothetical for the purpose of demonstration, what a low side user might see in their system once this process completes. So we can see we've got a task from the high side, and we can see that at 2034 on the 30th of the 5th, high side staff sent the following task to UKSV: check if James is really not a spy. And obviously that whole communication mechanism between this official system and the secret system can be two-way. So that's it. That's a very practical walkthrough of cross-domain workflows. What we've seen is that we can go from a user's browser with no connection to government at all, encrypt their data safely, send it all the way to a high-side environment, process it, deal with it, and then actually work between security domains in two ways. Now, cross-domain workflows are something which genuinely could completely change the way that we do cybersecurity in government. They're incredibly important, and actually they have implications for not just technical design, but user experience design as well. I hope you've enjoyed hearing a little bit more about cross-domain workflows, and really look forward to doing more work on this in the future.